Hello everyone. This is one of my commercial projects. It offers high efficiency and excellent durability, with a full range of built-in protection features, including output short circuit protection. You can download the project files from the link in the video description. Open the design files with Eagle, or use the Gerber files to order the PCB from JLCPCB. As with many of my other videos, JLCPCB is sponsoring this project by providing the PCBs. Many of my successful projects would not have been possible without their support. JLCPCB is currently offering great deals for new users, with many discount coupons worth up to hundreds of dollars. With advanced manufacturing technology, JLCPCB delivers top-quality PCBs and PCBA services. Sign up using the link below the video to claim your special offers today. After about a week, you will receive the PCB. This time I chose a black PCB. It looks better than the other colors. The quality of the PCB is still very good. This project has two separate boards. One is the power board and the other is the feedback board, which are connected by cables. Because I also sell boards with components for customers to solder themselves, I use mostly dip components. Soldering dip components does not require much skill or expensive equipment. First, we will solder the gate resistors for the MOSFET and the discharge diode. I use the FR107 diode, which is inexpensive and very fast. There are a total of 28 MOSFETs in this circuit. They form an H-bridge with 7 MOSFETs in parallel for each branch. The parasitic capacitance is quite large, which is why I need additional totem pole buffers. I use tip 41 and tip 42 transistors here. They are inexpensive and have a maximum current of up to 5 amps. You can also use D882 and B772 transistors. They are slightly weaker but still fully meet the requirements. When operating at maximum power, the current running through the circuit can reach nearly 200 amps. Reinforcing the circuit traces is very important. I will use copper foil to solder onto the circuit. You can also use 3mm copper wire for this purpose. A tip for soldering copper foil onto the circuit board is to use an iron underneath the board. Set the temperature to around 200 degrees Celsius. The board will heat up, and you can easily solder the copper foil onto it. These are 80N70 MOSFETs that I took from old circuits. They have very good quality and are very inexpensive. With 28 MOSFETs at 24 volts, the power can reach up to 3 kilowatts without any issues. Don't forget to reinforce the traces on the back of the board as well. They are also very important. I use 3 1000 nF capacitors to filter the input voltage. In general, the larger the capacitance, the better. There won't be any issues if you use larger capacitors. This is the feedback board, which functions for both voltage and current feedback. I use a small transformer here to isolate the 220 volts from the 24 volts. This makes it safer for the user. The feedback board will be connected to the main board through a cable. This is the sample product I send to customers. It uses a 3 kVA transformer weighing up to 18 kilograms. With 3 cooling fans, it can continuously operate at 3 kilowatts for extended periods without any issues. It includes overload protection, weak battery protection, short circuit protection, and can operate fully automatically when combined with an ATS, automatic transfer switch. Peak power can reach 6 kilowatts within 1 second. Maximum efficiency is up to 92%, with an average efficiency of 90%. I will test it with a 1000-watt hairdryer running at 1/3 power. The transformer, MOSFETs, and capacitors all remain very cool. The efficiency is approximately 90%, which is very promising.